Hey, this is Mr. Kelley, and we're going to be looking at what is called the scaffolded lab report. And a scaffolded lab report is what I'm giving to you as a guide, kind of showing you the format and what's to be included, kind of step by step over a formal lab report. And so you'll write up one of these scaffolded lab reports for every single lab that we do in class. So you'll take the data, work with your group members in class, and then individually you'll write up one of these lab reports. And then you'll share it back to me on Google Classroom. So to help you out, we're going to go through this kind of step by step, looking at each of these different elements, what they mean, and how to get the full 100 points on the entire lab. The very first thing that we're going to look at is a relevant title. As a good rule of thumb, you got to keep in mind that this is an English class. You're not looking for catchy titles or short, really abbreviated titles that kind of catch the eye. It's a scientific lab report, so your title should include kind of the words the analysis of or the effect of, and you're really looking at hinting at or basically explicitly stating your independent and your dependent variables in your title. And we'll get to what those are in just a quick second. So another student said that she felt like her title was really long, and that's kind of what it should be. You should have a long title. You're really kind of getting at what you observed in your experiment and what you changed to observe that. So next thing is your purpose and hypothesis. Purpose question is essentially, why were you doing the lab to begin with? And I know it's going to be tempting to say because you told us to, but you really need to look at kind of the question that you were trying to answer. So really, what were you doing in the lab? What were you trying to figure out? Hypothesis. This is very important. And the reason why it's important is because it really helps you out here on the independent and your dependent variables. So your hypothesis needs to be written in this format. If, then. So if, what is the experimenter changing? Then, what is the experimenter measuring? So all the hypotheses in this class need to be written in if-then format. And the reason why we write it in the if-then format is because what follows the if, that's our independent variable. And then what follows the then, that's our dependent variable. So independent variable is what the experimenter is manipulating or changing. Your dependent variable is what you're measuring. So what are you trying to figure out? What are you recording in your data table? That's the dependent variable. This is one that kind of stumps a lot of students right here. And control and constants are not the same thing. And that's why it stumps students. You want to stick to the fact that a constant is your control, but it's not. So a constant is things that stay the same. So it might be the temperature, it might be the cup size, it might be the amount of water, depending upon what the experiment, the constants are things that stay the same. The control is essentially kind of opposite of your dependent variable. So what are you doing or what are you using to compare to your experimental data? So your control is opposite your dependent variable. Control is not constant. Just make sure you're very much aware of that. Background knowledge. Kind of what did the lab look like when you came in? What materials did you use? What did you know going in? So when it comes to the fish respiration lab that we do as our first lab in class, kind of what did you already know about respiration rate and temperature? You might want to think about that for yourself. So background knowledge, lab setup. And once you have those two complete, you can delete all this. It's kind of like a little paragraph that you're going to include there. In this case, procedure, you can leave it as is. It's the same as lab directions. I don't want you to have to write out exactly what I said in class. I know what the procedure was. In the future, I'll have you guys write your own procedures, and you can revise this to include how you would conduct the lab. But in this case, all you have to do is write and leave it as same as lab directions. Data. This is very important. There's essentially going to be two data tables. First one is your controlled data, and the second one is your experimental data. So make sure that you include your data for both. And as a scaffolded lab, I have this already built for you so that you can go in and just insert your data and move on. So you no need to construct data tables on this first lab. In the future, you probably will be asked to make data tables. Qualitative data. So essentially, qualitative is opposite of quantitative. So all this above here, that's your quantitative. It deals with numbers. So that was degrees Celsius for temperature. For qualitative data, what you're going to do is you're going to describe anything that you saw in the lab. What did you see happening? So it could be the fact that at very cold temperatures, the fish was barely moving, or you saw it kind of settle in one spot in the tank. So remember that you want to be as descriptive as possible, and you really should include at least 3 sentences. Data analysis. So this section is your graph, so you can either do it out by hand and say that you're going to attach it, basically put it in the box, or you can actually use sheets.google.com and copy and paste your graph into your lab report. Kind of up to you. Next thing is describing patterns using raw data. So from the graph, what did you notice? What is the trend? So does the breathing rate increase, decrease, or is it remaining the same? And so this is very important. A lot of people will skip over this. You actually need to use actual data to back up your claim. So looking at the graph, talk about certain specific data points in your paragraph. And then lastly is the conclusion. And this is essentially kind of the CER, your claim, your evidence, and your reasoning, but in a little bit more detailed form. So the first thing is main idea. So going back to the beginning, your purpose and hypothesis, what you were trying to figure out, now having done the lab, you can answer that. So what is the answer to your purpose question? Next thing is you're going to restate your hypothesis word for word. So you can just copy and paste your hypothesis, and then now that you have your hypothesis copied and pasted, looking at your data, do you still agree with your hypothesis? Is it supported? Or do you reject it? So it's kind of looking at those data points again and saying yes or no. Reliability. So there was probably some things that went wrong in the lab or some things that make your data less reliable. So you're going to want to include that here. So essentially, if somebody was to go back and do this again, maybe they can correct those mistakes, or maybe they can recognize that maybe you got the wrong conclusion and here's why. Very last thing, application. So having done this lab, what could you use this information for in your life? And then lastly, what would you want to know if you were to do this lab again? So if you answer all those questions and fill in kind of all those boxes, you should be in good shape to get 100 points on your very first lab assignment or lab report. If you have any questions, feel free to comment on the video below. You could also email me or just simply come find me, ask me in person. And I hope that was helpful. Thanks.